Hi, this is Eros Borax, and this is my project for tutorial 14 and 15 using a motor drive. For this project, I have an LED, potentiometer, button, and motor, which are the things you'll be interacting with. And then behind the scenes, I have Arduino, a resistor, and of course the motor drive. And the idea of the project is that you have this potentiometer can control this LED, so it makes it brighter and dimmer. And then when you press the button, it switches over to the motor. So the light turns off, the motor turns on, and now that potentiometer controls the speed and direction of the motor. So to bring it all the way this way, it's going fast in one direction, and as I bring it lower, it gets slower, slower until it switches over. And it's kind of hard to see the speed on camera. Right now it's going fast in the other direction, and then it comes back, it's slowing down, switches over, and goes the other way. And then I press the button, and it goes back to the LED. So now this potentiometer controls the LED. For this tutorial, it would be useful to know what a motor drive is and what it does. So in most of my videos, I show you how the circuit works on the actual circuit with the camera first, but I think it would be easier if I show you how the motor drive works on this Tinkercad diagram first. So what a motor drive does is it makes it easier to control a motor. And how it does this is it essentially works as kind of a transistor, a complicated transistor specified to a motor. And on Tinkercad, they don't have the exact motor drive that I'm using, so I just used an IC that they have, which is actually also used for motor control, but it's just an IC. They have the same amount of pins, so it's wired the exact same as it is on my board, not to work for this IC. So you'll notice that there are two powers going to the board, this 5 volt and this 3.3 volt. And similar to a transistor, what the motor drive will do is it will use the 3.3 volts of power to power the board, and that needs to be exactly 3.3 volts of power, to transmit the 5 volts of power to control the motor. And that 5 volts doesn't need to come from the board. It can come from a battery or a power adapter or whatever, but I'm just using the board because it's easier. So I could use a transistor to do this. However, there are a few more functions that you can do with a motor drive, such as you can have it go multiple directions, you can control multiple motors, etc. But the concept stays the same, that it is using a smaller current to allow a bigger current to pass through into the motor. And different from a transistor, the smaller current is not determining how much the bigger current will go through. That is what these digital outputs are for. Now you notice there's 4 of them. This one here isn't super important. It just is always on in my code, and it just turns the board on and off. So in some projects, you'd want to be able to control whether the board's on and off. Mine doesn't matter, so I just have it set to always on. Now, these 3 here determine the direction and speed of the motor. This first one here determines the speed, and it is using pulse width modulation, or PWM for short. So it will simulate a higher or lower current with flashing a singular current on and off at an interval. And however much this is how fast the motor will go. And then these next 2 digital outputs are simply just on and off. And when one of them is on and the other isn't, it will go in one direction, and then when they're reversed, so the other one is on and the other one is off, the motor will spin the other direction, and when they're both on or both off, the motor will be stopped. So in your code, you can set those 3 outputs to what you want to manipulate how the motor will go. Then you'll notice that there's 3 grounds on the board, which all ground into the board, and they are for the 3 different systems that are on the board. So one of them is grounding for the motor, one of them is grounding for the board itself, and one of them is grounding for the PWMs. So now you can see the motor drive and how it is wired on my actual circuit. So here's the drive, and you can see that it works, or that it looks fairly different from the integrated circuit that I was using for the Tinkercad demonstration. And you can see I have the motor with its power and ground. You have the 3.3 volts of power used to power the board, and you have the 5 volts of power coming from the board. And I forgot to mention, this does need to be 5 volts. The board can handle anything between 5 and 12 volts, so it depends on what power supply you want and what your motor can handle. But I'm using 5 volts because it's on the board and it's the easiest to use. And then I have my 4 digital outputs and my 3 grounds that I all explained earlier. So you can see that this is the PWM cable going into the speed pin, and it comes into this digital output on the board. And then I have my direction pins here, and they go into these two on the board. And then you have this one, which is always on in my code, which is for the board to be on, and that goes here on the board. I'll also show you how the rest of my project is wired. So starting with the LED, we have that wired from a digital output on the board, and then the code will tell it when that is on, when it's off. And then we got a 100 ohm resistor grounding it to complete the circuit in this ground strip, which in turn goes back into the board. The resistor just to protect the LED. We got the potentiometer, and what a potentiometer does is when you turn this knob, it provides more or less resistance on the current going through it, and then the value of that resistance is fed into the Arduino in a digital input via this blue cable here, and you can use that in your code. So different values are given when this knob turns, and that's how I use it to control the speed of the motor and brightness of the LED. And the potentiometer gets its current from the 3.3 volts from the board along this power cable and then grounded into the ground. And then the button gets power from the 3.3 volt bar over here, and it goes into the push button, also called a momentary contact switch, and into ground with this 1000 ohm resistor. And this works is that when the button is pressed, the circuit is completed, and that information is relayed to the Arduino through this blue cable into a digital input as well. The potentiometer goes into an analog input, and the button goes into a digital input. So when this digital input receives current, it knows that the button is on, and I can use that for my code. And then when the button's not pressed, the current is not completed, so it doesn't receive an input. Now here's the schematic for my project made on Tinkercad. And first, it may look a little confusing. It can definitely be a bit to unpack, but it's really not too complicated if you really follow it through. So this is the motor drive, and you'll see I blocked out all the labels for the pins because they're incorrect, because as I said earlier, the IC that I used on Tinkercad isn't the actual motor drive. It just has the same number of pins, and it actually performs a similar function if you were to really use it, but it's not the same, and the pins aren't in the same order. So starting off with the motor drive, I'll start off by showing the grounds. So this is the ground strip here on the board, and you can see it goes into the motor drive 3 times here, in through here, and in through here. And one of these is for the board itself, one of them is for the motor, and one of them is for the digital outputs that come from the Arduino. And speaking of the motor, here you can see the motor comes out from the drive through the motor and back into the drive. Next, you can see the digital outputs that come from the Arduino into the motor drive to determine the speed and direction of the motor. And they are here, here, and here. Now you'll notice that this output 4 offshoots into all of these, which also go into the IC. And that's related to what the IC does if you were to use it for its own purpose. But for our purposes, these don't really matter, and it only matters that digital output 4 comes into here. And then lastly, you have the power coming into the motor drive, the two of them, the 3.3 volts, which is the strip here that comes from the board, and it comes here into the motor drive, and then the 5 volts, which also comes from the board, which powers the motor, which goes into the motor drive here. The next on the parts of the circuit coming from the Arduino, we have the LED, which comes from ground from the board into the LED through the resistor and into the digital output of the Arduino. I just followed that in reverse because it's easier to start in reverse from the ground for these. Then we have the potentiometer, which feeds its analog input into the board and takes its power from the ground through the potentiometer and into this 3.3 volt strip, which in turn comes from the board. And then you have the button, which comes from the ground here, and you can follow that here through the resistor, then through the button, and then into this digital input to the board. Here's my code written in C++ on the Arduino IDE. So here, starting off the code, before my setup loop or main loop, I'm creating a couple variables as global variables so I can use them anywhere in my code regardless of scope. And they're all constant variables. These three, I'm calling them direction A, direction B, and PWM, and I'm setting them to 5, 4, and 6 respectively. And that's just to make it easier to type out when I'm telling the motor to turn on and what direction to go. I don't need to remember which digital output corresponds to what function. I can just type direction A, direction B, or PWM, which is the speed, without having to remember the numbers. And then this is for the button loop, which I will use to determine whether the potentiometer is controlling the LED or the motor, which in this changes with the button, hence why it's called button loop. I'll get to this more later in the code. And this pot max, which is the maximum value of the potentiometer, is important, and I created this variable because the potentiometer isn't great, and sometimes it'll give different readings. So sometimes the maximum value that it will read is different from other times. So instead of having to change it every single place in the code, because I use that maximum value a good amount in my code, as you'll see. So instead of having to change every single instance every time the potentiometer changes its value slightly, I can just change this one variable up here, change just one number, and that variable is changed throughout the whole code. Super useful. Then next here in the setup loop, so this will run once, I first declare all of the digital input-output pins that I'll be using as outputs, and then these are for the motor drive, and this one I believe is the one that keeps the motor drive on. And here I'm initializing the serial monitor, so I will use the serial monitor to print the values of variables, which is helpful for debugging. And this 9600 means 9600 refreshes per second, or minute, sorry. And then next in the void loop, which this code will repeat over and over again, I first declare these two variables called press and pot, and these are just shorthand for the button and the potentiometer, so I can just type press or pot instead of digital read 2 or analog read 0, makes it quicker. And then here, in this if loop right here, which extends all the way down to here, this is where I have the button change which loop you are in. So I default to, if you remember up here, I default to button loop starting in 1. So here, if press equals 1, or in other words, if the button is pressed, then I have another if loop. So if the button is pressed, if the button loop equals 1, then button loop equals 0. So it flips. And then in this same if button pressed, the else for this loop is if button loop equals is the else that button loop is set to 1. So in other words, if it's equal to 1, it's set to 0, and if it's set to 0, or the other possible condition, then it's set to 1. So basically it reverses. And then I delay for 60 milliseconds so you have time to press the button, because if this weren't here, you need to kind of press it instantly, but now you have 60 milliseconds to press the button before it doesn't work as it should. So now next, in that loop, but if button loop equals 1, which is all the way down to here, which is determined by this pressing, I have all the code that has the potentiometer control the motor. So here, analog write 10-0 just turns the LED off, and digital write 12-1 turns the motor drive on. I referenced that earlier, how the motor drive is a pin that needs to be turned on for it to turn on. And then here, I'm creating 3 variables that will represent the 3 things that the Arduino needs to tell the motor drive to do. And they are the direction A, direction B, and speed. And I talked about these 3 things earlier. Now here, this is where that pot max I talked about earlier comes into play. I'm mapping the potentiometer's readings onto these 3 variables here, and then I'll later use these variables to dictate the motor. So here, if the potentiometer reading is less than 1/2 of the potentiometer max, this is if the potentiometer is in the first half of its reading range, I have A set to 0, B set to 1, and speed set to a map, and I'll explain that just in a sec. So A0 and B1 is the first direction, because remember, the motor drive will receive 2 direction values. So if A is 0 and B is 1, it'll go in, I believe, clockwise. And then this right here assigns the variable speed to be a map of the potentiometer reading on a scale of 0 to that pot max divided by 2. So in that first half of rotation. So from here to here mapped onto 255 to 0. So reverse of 0 to 255, so that my potentiometer is down here. It's going fast in this direction, and as you work your way up the potentiometer, it gets slower and slower until it reaches 0 at pot max divided by 2, or halfway up the potentiometer. And that's why it's very useful, you can see, to have that pot max be a very changeable variable if the value is fluctuating, so I don't need to change it all of these times. And then just like I had it before, but for the other half, I have if the potentiometer reading is greater than 1/2 of the potentiometer max, I have it go the other way. So direction A equals 1, B is 0, and speed is a mapping basically the other way. So from pot max divided by 2 halfway to the potentiometer max. So from this part of the revolution to the maximum amount from this, and then from 0 to 255. So when it's here, it's slow at 0, and then it gets faster and faster to down here, where it's at 255. The analysis is just if it's directly in between, if the reading is not less than or greater than halfway, just set everything to 0 so that the motor is stopped. Now down here, the code is actually telling the motor driver to run the motor. So digital write direction A, remember I used this variable earlier to represent the pin that direction A is being sent to. Direction A, so that is either going to be 0 or 1, depending on where the potentiometer is, and then digital write direction B, so that's setting to the direction B pin B, which is either 1 or 0, depending on where the potentiometer is. And then I'm analog writing the PWM pin, which I assigned earlier. The speed variable. So the speed is the map from 0 to pot max from 0 to 255, which is what the motor runs on, depending on where it is in the potentiometer range. And then here, I'm just printing all those to the serial monitor, which you'll see later in the video. And I have labels, variables, and then delaying by 50 milliseconds so you have time to read the print. So next, down here, I have an else if loop for that previous if loop, and this just serves as the other button loop. So you'll see here if button loop equals 0, which is the other mode that I could be in, I control the LED. So the potentiometer is controlling the LED instead of the motor. And similar to the button loop equals 1 loop, the first thing I do is I turn the motor drive off. Last time I was turning the LED off and the motor drive on. Here I'm turning the motor drive off. Then here I'm creating a variable called LED, which is a map of the potentiometer reading on a scale of 0 to the maximum potentiometer value on a scale of 0 to 255. A lot simpler than the motor one, because I have it where if the potentiometer is all the way down here, the LED is off, hence they both get 0. As it works its way up, as the potentiometer makes its way up to its max part of its revolution, the variable will get closer and closer to 255. Then here, I'm writing to the LED, which is in pin 10, that value. So wherever the potentiometer is, it will correspond to this variable, it will change this variable, and this variable gets fed out into the LED. And then here I'm just printing the variables used here in the serial monitor. Last but not least is the serial monitor printouts. So as you can see here on the serial monitor, it is printing several values with labels. We've got button loop, potentiometer, speed, and press. So button loop indicates what loop the code is in, whether it's in the LED loop or the motor loop. Pot refers to the reading of the potentiometer. Speed is the speed that the motor is running at, and press is whether the button is pressed or not, with 0 being not pressed and 1 being pressed. So right now you can see that potentiometer is right around 870 or so. It fluctuates quite a bit, and speed is almost at its max. So this is almost the max of the potentiometer, and speed is almost at the max, which maxes out at about 255. And as I move the potentiometer, right, potentiometer reading goes down, and because of that, the speed value goes down, and because of that, the actual speed of the motor goes down. And then you'll see as I switch over, it stops and then starts going the opposite direction, with the potentiometer being on the other side, so the potentiometer value is much lower, but speed is working its way back up to 255, where right now it's about that maximum value and the motor is going at full speed the other way. And when the potentiometer value doesn't have the same amount of digits, because it's fluctuating between 1, 2, and 3 digits, it prints a little messy. So I'll bring it back up here, where it's printing a lot cleaner. Then I'm about to press the button, and you'll see momentarily the press value will change to 1. I don't know if you'll be able to catch it because it's quick, so I press the button quickly. And now it changed. So you'll notice the numbers are the same, except that the speed changed to LED. So now instead of how fast the motor going, it's still between 0 and 255, but it represents the LED variable and how bright the LED is. So you can see that I'll bring it all the way down. You see that they're all at 0, meaning that the potentiometer is all the way at 0. Thus the LED is at 0 and completely dark, as you can see on the LED. And press is 0, meaning the button is not pressed, and button loop is 0, which is just the state it's in. And then as I increase the potentiometer value goes up, and thus the LED variable goes up, and thus the LED gets brighter and brighter until it makes its way to the maximum value, and you can see that the LED variable is just at about 255.